so number 14, we are trying to write a polynomial that has the given zeros. Okay, so they gave us 2. They told us that 2 of the zeros are -3 minus 2i and -I. Well, complex zeros are the same deal as irrational zeros. They come in pairs. So if -3 minus 2i is one of our zeros, then -3 plus 2i is automatically also a zero. And if -I is one of our zeros, then positive I is another zero. So they only gave us 2, but this is a 4th degree or a quartic polynomial. Okay, it is a 4th degree, or you may see the term quartic as well to describe that polynomial, even though we just started with 2. Okay, so let's put these into our factors. Now, this is just personal preference, but I'm going to put the I and -I in first. Okay, I'm going to do those first, and then I'm going to put in my other ones. Now, remember how we did this with the irrational. We put the 0, we put a minus sign, and then it's followed by the 0. And then we'll go through. If you can change the signs when you plug them in, that's fine. I think it's just a lot more, it's easier to deal with if you put the minus and then you just take one more step to change the signs. Okay, I want to pair these up when I multiply them out, because it's like with the irrational. Remember with the irrational, our square roots ended up canceling out. Well, a similar thing's going to end up with our i's. They're going to end up taking care of each other if we pair them up with their conjugate. So when we multiply x plus I times x minus I, x times x is x squared. X times -I is -ix. Positive I times x is positive ix. And positive I times -I is -I squared. We'll simplify that here in a second. Okay, as far as these parentheses that follow, I'm going to distribute my negatives, so that becomes x plus 3 plus 2i and x plus 3 minus 2i. Try not to do too many different things at one time so you don't get confused. Okay, so back to that first set of parentheses. -ix and positive ix, they cancel with each other. So we've got x squared. Now, does anybody remember what I squared is equal to? -1. So we've got minus a -1. You don't want to leave the I squared in there. You need to replace I squared with -1. But there was a minus in front of it, so we've got to keep the minus, and it is -1. Okay, which subtracting a negative turns into adding a positive. Okay, so x squared plus 1 is what gives us zeros of I and -I. All right, let's proceed with multiplying out the second 2 sets of parentheses here. Okay, distribute the x to everything. Okay, x times x is x squared. X times 3 is 3x. X times -2i is -2ix. Distribute the 3 to everything. 3 times x is 3x. 3 times 3 is 9. 3 times -2i is -6i. Distribute the 2i to everything. Plus 2ix plus 6i minus 4i squared. When you multiply positive 2i and -2i. Okay, so hopefully, there's a lot of terms in there. Hopefully some things cancel out, and they do. -2ix, positive 2ix, cancel out. -6i plus 6i, cancel out. Those are the only things that looks like cancels, but then we're going to be able to simplify some stuff. Let's go ahead and here at the end, the -4i squared. I squared is -1, so that's really -4 times -1. So when we come down here on the next line, and we're simplifying, we've got x squared 3x and 3x is 6x. And we've got 9 plus 4, because it was negative 4 times negative 1, so that's positive 4. 9 plus 4 is 13. So we just took something that looked really, really, really complicated, and it boils down to just a quadratic. Okay, we got 2 more steps. Okay, we've got to distribute that x squared plus 1. So x squared times x squared is x to the 4th. X squared times 6x is 6x cubed. X squared times 13 is 13x squared. Distribute the 1. So 1 times x squared is x squared. 1 times 6x is 6x. 1 times 13 is 13. And then finally, all we have to do is combine our like terms. X to the 4th plus 6x cubed plus 14x squared plus 6x plus 13. Okay, so it takes a little bit of work, but if you pair things up correctly, a lot of stuff's going to cancel out and it's not really going to be that bad. So always multiply out the 0 and its conjugate. Okay, don't try and mix the x plus I with the x plus 3 plus 2i. Okay, you can multiply those out. It's just not going to cancel and simplify and look as nice and neat until you get to the very end. You're going to end up doing more work than you really need to do. Okay? All right, so practice with these for a second. 15 and 16 on your worksheet there are complex zeros or roots